Okay, today we are going to differentiate arcsecant x. Now, the first thing that we have to remember is the inverse relationship of arcsecant x, which states that arcsecant x equals y is the same as secant of y equals x, okay? So this is actually the formula that we're going to use to derive arcsecant x. Now, we're going to use implicit differentiation to derive the inverse formula of arcsecant x today. And so what we're going to do is we're going to differentiate both sides of the equation separately. We're going to derive secant y with respect to x. So we're going to have a chain rule there. And we're going to derive x with respect to x, which is just going to be 1. So here we're going to end up using the chain rule, which means we're going to actually be deriving secant y with respect to y and multiplying that by the derivative of y with respect to x, which we're going to be solving for because this is the slope of the tangent line. So we're going to be trying to isolate that. So that's going to be our third step. I could put that all in one step, but it might be a little bit more clear if I change colors here. So we're going to divide by the derivative of secant y. Now, the derivative of secant y is cosecant y. The derivative of secant y is not cosecant y. The derivative of secant y is actually secant y tan y. Okay, so we're going to get secant y tan y times dy over dx equals 1. I'm going to write it out because there was that little bit of confusion there. Now we're going to divide by secant y tan y, and we're going to end up with dy over dx is 1 over secant y tan y. Now you may be confused at this point because so far we've done inverse derivation where you have one trig function in the denominator, and it's pretty easy. You draw a little triangle, you find the missing length. It's fast. This is a little bit more complicated, but really not much. It just looks a little bit intimidating. The first thing we're going to do is remember that secant y is just x. So we actually have dy over dx is 1 over x times tan y. And now we can do what we usually do. We can draw our triangle. Okay. And keep in mind that we know that sec y is x over 1. And we know that x over 1 is equivalent to hypotenuse over adjacent, because sec y is 1 over cosine, and cosine is adjacent over hypotenuse, so we're just flipping it, right? They're reciprocals of each other. So that means that we know that the hypotenuse is x, the adjacent of our angle y, which is right here, is 1, and that therefore this length, I'm going to do it in a different color, and that therefore this length is x squared minus 1 squared, which is just x squared minus 1, because 1 squared is just 1. So this is what we're going to use to solve this equation. Now we have dy over dx is 1 over x times tan y. And we know, make a little note here, we know that tan y is opposite over adjacent. Here, opposite is this length that we just got with the Pythagorean theorem. And adjacent is 1, so it's just going to be this length, right? It's going to be the square root of x squared minus 1. And that is our solution. Let's write it down correctly, though. Let's write down our initial formula. And we're going to have the derivative of arcsecant x with respect to x is 1 over x times the square root of x squared minus 1. There we go.